Hello, hello everyone. Nice to be there again. Welcome to this new installment of the weekly gossip news. Um, so, as a reminder, we are building this chat app, decentralized, encrypted, post-quantum, no metadata, secure, and that responds to the actual needs of people on the terrain. So, here are the latest news. First of all, we made quite a few improvements on the software itself. There's various small enhancements, improvements, bug fixes, etc. Uh, we have made a full migration to the Gossip SDK. So if you remember in one of the previous calls, some of you asked for the system to be cut into smaller libraries so that people can use pieces of it or even in the future integrate it inside existing other software as like a chat box or something. So this was done. It's operational, so it's been deployed. We also have implemented the deduplication system for messages. So sometimes because sessions break, etc., we need to resend messages automatically. And now sometimes you would receive the same message multiple times. Now it's deduplicated automatically. So that's one major improvement. Um, there's also some work in progress. The first of all is the session maintenance system. So the sessions need to be robust, even if there is loss of connection, if there's any kind of issues with the gossip itself. So that's being reworked as we speak. We're implementing a completely new version that's more robust. Stay tuned for this. And the last thing that I'm gonna talk about now, we are also implementing currently the plausibly deniable session system. I'll tell you more in a minute. So for those who want to play already with what's already been implemented, feel free to try. There's quite a few UX improvements, bug fixes, the SDK system, the application that's already working. So feel free to download it, install it, and try it. It's been updated on the website, so feel free to try the new version. And of course, give us feedback if you see any issues. Now, I'm gonna talk to you about something that we've been working on recently. It's called plausible deniable sessions. So what's the general idea? General idea is that if you look at what many of the journalists that we talked to told us, or even what many journalist associations mention, is that more and more when journalists, for example, cross borders, the border guards just take their phones, they open them, they scan them, and they check for anything weird inside. So of course, if the storage um, is not encrypted, they're gonna find all the stuff inside, all the contacts of the journalists, all the sources, and many journalist associations are actually calling a warning on that right now, because the U.S. Customs and Border Protection is actually multiplying the number of inspections on physical devices every year. But it's not only the US. Many countries are doing it. Here's a few examples. In Israel, it's almost systematic for high profiles. In Canada, it's now very common nowadays as well. And it's growing many countries around the world. And for many journalists, it's a question of life and death when it comes to sources. So this is a big issue, and we're trying to solve it. Some would say, well, just encrypt the data, right? Unfortunately, it's not as simple because if you refuse to give away access to an encrypted content on your phone, it's suspicious and you can actually get arrested for that. So you need to give a password. You need to give them access to your session. And unfortunately, the only way that journalists have today is to save somewhere all the content, back it up on some cloud somewhere, delete the app, delete data before crossing the border, and then after they cross the border, reinstall everything, decrypt it, etc., etc. It's very heavy and it's not very satisfactory. So we need to find a way to have that keep the data on the phone, not have to uninstall anything, and be able to give access to something to the authorities if they ask for it, without giving access to the sensitive stuff. And of course, without the authorities being able to mention that, to see that there is anything more there hidden. So how do we fix this? Our idea is to have multiple sessions in Gossip. Each session would be protected by a different password. So when you open the login screen, you can log in with the biometrics directly with your normal session, or you can type a password. And if this password unlocks one of the hidden sessions, it's going to open the hidden session. If it doesn't, it won't open it. So this is already what some other apps, I think, if I'm not mistaken, Session does that, SimpleX. They kind of have these hidden sessions, but the problem is that they're not plausibly deniable. If the authorities know that you unlocked one session, they will be able to look, and they will know 100% that there is other hidden sessions. And then they will, of course, ask for the password of the hidden sessions. So we need a way to have something that's plausibly deniable. Something where if the authorities look, even if you have unlocked one session to show them, they look at the contents of the drive of the phone, they should have no clue whether or not there's other sessions, how many sessions there are, they should have no idea. So that's called plausibly deniable sessions. And to our knowledge, maybe we missed something, but we did some research and we might be the first ones to implement this. And the way to implement it is the following. That's how we chose to implement it. There's basically two areas in the memory. One area of 2 megabytes that we call the addressing blob, and one area that's called data blob. Both are filled from the outside by something that looks like randomness. And the way it works in general is that the user will enter a password. There's going to be a safe post-quantum key derivation function that prevents authorities from brute forcing passwords. It takes forever to compute this, basically. And from there, the key derivation function is going to derive an index inside this addressing blob among 65,000 elements and a set of cryptographic keys. Then the system is going to look inside the blob on the element that's indexed by this index. And this element is going to give us the offset and the size once decrypted using one of the keys here. It's going to give us the offset and the size of where the first block of the session is inside the dynamic blob of data. And from there, we are also going to use one of the keys derived by the KDF to try to decipher what's there. And if we fail to decipher it, then it's the wrong password. And from the outside, all these looks like a random blob of data. In practice, this data blob here at the bottom is full of random padding, so random data is actually random, and blocks of pieces of sessions that are also interlaced between them. We choose the sizes of the padding and the sessions in a very smart way so that nobody knows whether there's 1, 2, 3, 4, 5 sessions. They have no clue. And the addressing blob here is the same. Everything looks like pure randomness. When you look up using the index and the keys, you decipher what you find, whatever you find there, you decipher it using one of the keys, and that gives you the address of the encrypted blob. There you use the other key and you decrypt the blob here. We did some math. This exact design is a bit tricky because there's only 65,000 blobs here. So if you have, let's say, 1,000 sessions, there's a non-negligible risk that by adding one session, you overwrite the blob of one of the existing sessions, and that's an issue. So we worked on the simulation. What's the likelihood of a failure, of overwriting, completely losing an existing session by adding 1,024 sessions with 65,000 slots in the addressing area. So what's the probability of losing at least one element, assuming that instead of saving only one copy of this address here, we save many copies of it. And when we do the KDF, we derive all the indexes and all the keys, and we look at all of them individually until we find one that actually decrypts. So intuitively, you understand that if we don't make enough copies, we're gonna end up in the same situation as we have now. So it takes just one other session to overwrite one of our keys, and we lost. And the opposite is true as well. If we replicate too many times, then also we're gonna overwrite the entries of the other sessions more often. So it's intuitive that there's some kind of sweet spot, and we did the math, we did a Markov chain simulation, and the probability of losing at least one session falls to the 10 to the minus 12 almost at exactly a minimum of 46 replications. So it's completely negligible. So if we replicate each session address 46 times in the addressing blob, we're safe. So that's what we did. And now the system is fully specified. You'll see there's many other subtleties. For example, how we handle the growth of the dynamic blob here while remaining plausibly deniable. So feel free to check it out. It's all specified in an open source fashion here. So it's in the gossip discussions. It's the discussion number 321 on GitHub. Feel free to check it out if you have any comments. To our knowledge, it's a completely original way of doing this. It's the first time somebody implements something like this. So it's not there. It's not there yet inside the Gossip app. It's actually being implemented right now. It's not been deployed in this version now, but it's gonna arrive soon. And what to expect there? There should be Gossip should be the very first chat app with true plausible deniable sessions. So you can have, for example, sessions where you talk to your parents, your grandma, whatever, and sessions where you're a journalist and you talk to your sources, and even the third session where you talk to other people and maybe compartmentalize different sources. And when you pass a border, you can just show the password of your chats with your parents, for example, and they will be able to decipher it. They'll be happy, and they have no way of knowing whether or not there are or not more encrypted sessions on the device. And that's the most powerful thing. And of course, the impact on the UX should be minimal. There should be barely any impact. So stay in touch. Stay tuned. It's not all finished yet. It's being implemented, and this is one of the few features that were asked to us by journalists and various kind of activists around the world. So we're trying to implement this. As soon as we have it implemented, we're gonna give you a demo, of course, and that's about it for today. Feel free to try the new app. If you have any people around you that require freedom of speech, feel free to direct them to us uh, for them to tell us whatever they need, whatever we can implement, whatever we can improve. Also, feel free to contribute. Everything is on GitHub, so feel free to check it out. Contribute, give us feedback, try it. If there's bugs, tell us. Somebody's asking, what if the Popo take the phone and perform a forensic analysis? Can they see it? Exactly, that's the whole point. If they open the phone and they do a forensic analysis, they will see an encrypted blob of data. They don't know, it looks like random data, and they have no way of knowing how many sessions there are there. So even if you give them the password of one of the sessions, they're gonna decrypt it, and they're gonna see the content of the session. They still don't know if there's others or how many others there are, and that's the beautiful thing. It's not just like some other chats do, hiding the other sessions in the list of sessions at the beginning. It's actually plausibly deniable, and that's powerful. Yeah, so that's great. We also reinforce security against the authorities taking a snapshot when you enter the country and when you exit it, and looking at the difference. We also have protection against that up to a point. No, they won't. So would they still be able to see that we're hiding something based on the storage? No, actually. Look at the specification. It's beautiful. It hides even the fact that there's more sessions. You don't know. No way of knowing, or at least no way of being sure. Okay, if there's no more questions, so that's about it for today. Feel free to test the system, play with it, and give us feedback. The next steps are going to be implementing this system, of course, improving the session reestablishment system, and we start the groundwork on specifying the next steps, which are building the backend to make the system work even when there's low internet connectivity, even if there's areas of high censorship, even if internet is blocked, we should be able to function. So stay tuned. The next steps are very promising, so very excited to show you that. And thank you for being there. Bye.